Thank you for joining. So I will tell you a story today. One day while we were reviewing the results of our pipeline execution, I realized that our tests were taking longer and longer to run. And we were experiencing a lot of crashes, browser crashes. So these tests that we had already been taking a considerable amount of time to execute. But over the course of a year, maybe each time a new test was added, the execution time increased almost exponentially. So by the time our team became aware of this issue, the tests were taking 10 hours to run, 10 hours. And it was obviously clear that something urgent needed to be done. So my name is Alejandro Brugarolas, and I'm a senior quality engineer at Red Hat, and also a computer science professor in Spain. I've been using Cypress daily for over 3 years, maybe, and I've been also teaching Cypress in Spain to my students as part of their QA training for just as long, 3 years. When I joined this project, I'm going to tell you about right now, I had only developed a few tests with Cypress, and in general, my experience in QA was quite limited, having written some automations in Selenium and a small scrapper in, I think it was called Nightmare.js. I'm not even sure it still exists. So when I started to use Cypress, I began studying the documentation, learning about best practices, and engaging with the community in order to truly understand how this framework works. Hey, I'm seeing the chat, Nightmare.js. Okay, so to understand this story, we need to understand the uniqueness of the project it is part of. Conveyor is an open source project that facilitates the task of migrating application across various languages to more modern cloud native technologies. One of the key features, and this is important for later, one of the key features of this project is that it allows applications to be analyzed, applying rules to determine the effort required for migration. So those are tasks that can take a lot of time. In this project, we have components testing, CLI testing, API testing as well, and we only use Cypress for end-to-end UI test. These are divided into tiers that run on different platforms and also on different occasions. However, every time there is a new release, we run the entire suite. Additionally, this is a project that is growing at a fast pace. So sometimes, and I believe that this is something that also happens to most of you, sometimes the speed of automation development can't keep up with the speed of feature development. So this usually introduces some flakiness and also reduce the quality of the code. So right now, this is the situation we were having before starting to act. Currently, our suite had over 500 end-to-end tests, all of them developed over the years. And a few months ago, the full execution time took more than 10 hours. So after realizing that the situation was unsustainable and much harder to scale, we started working on investigating the problem, and we started to invest some time in this. At the time, our suite wasn't parallelized at all, and the tests were even coupled, meaning that it wasn't possible to run a single isolated test. And sometimes we even depended on the order of tests of the suites for the test to pass. The situation meant that if someone wanted to manually execute the UI testing pipeline and see the state of the product at a given moment, they had to start the execution and they wouldn't see the results until the next workday. And this in the best case scenario. If for any reason the pipeline failed, they will have to repeat the process. This caused the UI end-to-end test to stop being executed as part of our usual workflow. So when a pull request was merged, the tests weren't executed at all. And even if they were run as part of the CI, it will merge. People will merge the change with failed checks. So this leads to a total distrust in the test and ignoring whether the new feature had introduced any bugs, because we were ignoring the results. After investing some time, our investigation concluded that there were a minimum unavoidable execution time that we had to accept, as it was limited by the time required for those analyses that I told you about before. There was some minimum time required for those analyses to run, and we didn't want to use dummy data to ensure the closest possible resemblance to a real environment. And secondly, most of our tests weren't currently cleaning up the data and elements they use. So this led to accumulating elements in the interface, causing each test to deal with data from previous tests. Thirdly, this increased resource consumption by a lot. And another important factor was the sheer volume of logs, UI logs generated by our test. Our test executed hundreds of operations and recorded thousands of HTTP requests. All of this information reflected in the Cypress logs that was loading an insane amount of elements in the DOM. All of this led to some tests not even running because the browser crashed before it could reach those tests. Once the problem was identified, it was time to get to work. And the strategy was clear. First, we will reduce memory consumption to prevent tests from failing to execute. This is the first point, and also this is the most important point, because many times we overlook memory usage because we assume that we have enough resources to run everything, and now we have good laptops, good PCs, so we overlook memory usage. But proper memory management is the key to achieve optimal performance during the text execution. Because since in Cypress, our tests interact with the application just like a user would, the better we manage this memory, the better and faster our tests will run. Then after that, we will improve the text execution speed. And last of all, we will reduce the flackiness that could arise from residual information left behind by other tests. And also, we needed to check that the speed improvement that we didn't cause any more flackiness. I'm seeing the chat, experimental memory management coming. Yeah, absolutely. So before reduced memory usage, we had to ensure that our tests were indeed using excessive memory, of course. So we made use of Cypress debugging tools to identify the issue. Cypress uses the debug module, which means that we can set the environment variable debug with a series of parameters before running our test. Displaying all debug logs could generate large, insane, again, amount of logs. And this will lead to, this will further reduce performance. So we had to use some of the selectors provided in the documentation to limit the information we received. Since the tests were already failing and crashing due to memory issues, adding another process that generated even more logs, even if not in the UI itself, that presented a significant challenge. In the end, by adjusting the log collection and also the display intervals, we were able to gather a series of logs during each test. And at the end of the full execution, this gave that, in this case, with the logs displaying, took like 12 hours, if I remember correctly. At the end of the full execution, this gave us a global view of resource consumption at each moment, and we could start taking action for real. So, as someone already said, to reduce memory consumption, we use several strategies. And the first one, we noticed an improvement by simply enabling the experimental memory management in the configuration. Although this wasn't going to work well because it was specific to Chromium, but it showed some improvement. However, this is not the total solution. This is not the total solution, and because it is an experimental feature, and this affects only Chromium-based browsers. So since it's an experimental feature, it could change or even be removed in the future. So it wasn't the best option in the long run. The next step was addressing the issue with logs. With so many logs, the DOM will fill in open mode with HTML elements to a level that it will occasionally cause the browser to crash. To avoid this, we had several options, and one was to completely remove the logs from the CI. But we discarded this because we heavily relied on the screenshots taken by Cypress for debugging file tests. So we were saving a lot of screenshots when we had flagginess and when we had a new feature that break our UI test. We used the screenshot with the logs, of course, to debug the fail tests. So after not finding a satisfactory solution, I decided to leverage Cypress' ability to create plugins and develop a small extension that would allow us to modify the log level displayed during execution. This worked whether in CI or in Cypress open mode. This extension allows us configuring the logs to be displayed at 4 levels, allowing us to work with all logs locally while developing automation and limit them in CI to the assertion level, meaning that we will only see assertion and not every step. This significantly reduced memory consumption while still allowing us to debug tests in the way that we were used to. If you're interested, the extension is called Cypress Log Filter. It's open source and available for installation via npm. Here is an example where we can see how Cypress Log Filter plugin works in Cypress open mode. As you can see in the top left, there is a drop-down showing different log levels. Since it is set to assert, we don't see the logs for UI operation events. We only see assertion and errors. So that was all for the logs. Now, having reduced memory usage and crashes, the next step was to improve the speed of text execution. This time, this was a long but relatively easy task because we only had to review Cypress best practices and refactor the legacy code that hadn't been touched in years. And that the legacy code was the foundation of everything. Due to how the tests were designed years ago, there were many explicit weights in the code. And I told you, be ready for what you are going to see next. Due to how the tests were designed, and there were so many explicit weights, and by replacing them with assertion, with timeouts, not only did we reduce execution time, but we also eliminated much of the flagginess in the test. And we reduced the number of commands used by eliminating common action that had their own specific test. For example, we were checking that after every operation, we will see the notification appear. For example, creating something, we will wait until we saw the notification. We removed those checks from most of the tests, and we created some specific tests just to check notification and to check that they appear after execution operation. And finally, many of our tests were coupled by definition. So after a significant effort, and this was a really big effort, to isolate them as much as possible, we were able to parallelize part of them, not all of them, which, as you can imagine, made everything run more smoothly and reduce execution time, cutting the total time by 50% after applying all these changes. So be ready for what you are going to see right now. As part of eliminating explicit weights, while I was searching for all instances of CI weight in the project, I found things like this. The first image shows a snippet of the function used to login. While we store authentication cookies, most tests perform the login in the before all hook. With some of our tests were opening and closing sessions multiple times, even with different users, different roles, and that sort of thing. So as you can see, the second line of this function is an explicit wait of 5 seconds. So now think that if each one of our more than 100 spec files does one login, just the first line of each test added almost 10 minutes to the total execution time of all suites. I know just 10 minutes doesn't seem a lot when you are talking about 10 hours, but every change made the execution time better. And in the second image, we see something worse. The function itself is not even a command, okay? It's just a click triggered after a contains selector, after selecting something with contains. So Cypress documentation advises against abusing commands or functions like this, but But as I mentioned earlier, we all generate legacy code. And since it was at such a widely used and trivial function in the project, we never stopped to think that it could contain an error. As you can see, the second line is an explicit wait of 1 second. Now imagine for a moment having to wait 1 second for every click you make in real life. Obviously, eliminating this explicit wait had almost no impact on text execution, thanks to Cypress retriability, and it significantly reduced execution time. So after all this, we wanted to go a step further and adopted the DS-Build runtime via a Cypress plugin again, which reduced the startup time of some specs files by almost half. For those unfamiliar with ESBuild, it's a bundle and a minifier. It's written in Go, and it's optimized for speed. So unlike Webpack, for example, ESBuild is designed to be highly optimized for speed. So it's ideal for packaging tasks during development. And implementing it was really easy because there was, again, a plugin called Cypress ESBuild preprocessor. With fewer than 30 lines of code, we managed to reduce loading time of each spec file from around 5 seconds to 3 seconds. Given that we have more than 100 spec files, this small change reduced the total time by more than 5 minutes without impacting the development of automation. Also, as I mentioned earlier, we had several operations that took quite a while. For example, analyzing an application. These operations were controlled by polling before. This generated unnecessary commands and unnecessary logs. After replacing them with more specific timeouts focused on each task, we achieved a reduction of 1 hour in the total test execution time. In this example, we can see one of the changes from a recursive function that did polling to check the status of an asynchronous operation in the application. This function, in addition to using an explicit wait, as you can see, call itself until the operation complete. Also, assuming it will always finish. If the operation failed or took 1 hour by mistake, the function will have generated so many logs that the browser will have crashed. On the right image, we have the updated version, where polling and explicit waits were replaced with a predefined but configurable timeout, adaptable to each operation. This not only made the code much cleaner and more readable, but it also improved execution speed and resource consumption. So at the end of all of this, we managed to reduce execution time from 10 hours to 4 hours across all tiers. It is still a number that's a bit intimidating, I know, but it is expected considering we ran some load and analysis tests that increase the minimum time for execution. So this is now expected. And memory consumption was reduced, leading to cost saving and greater stability in execution. And this also increased confidence in CI/CD pipelines. So ultimately, this improved the product quality, which should be the main goal of end-to-end UI testing. The moral of this story is that it's important to analyze our code because, and this is really important, just like developing features generates legacy code, we also, QA people, we generate legacy code when we wrote tests. That's inevitable. To improve our legacy code, one of the steps should be to consult Cypress best practices and ensure we follow as many as possible. Sometimes it's not feasible to follow them all, depending on the unique characteristic of each project, but we should aim to follow as many best practices as we can. And lastly, to get the best experience with Cypress and make the most of it, we can take advantage of. Okay, as I was saying, using Cypress plugins, we can take advantage, and because they are incredibly varied, and they have Cypress has a plugin for practically anything we might need. So finally, now for real, at Conveyor, we always looking for new contributions. So feel free to ping me if you want to participate in the community or maybe join a community meeting to learn more about the project and get involved. So now for real, thank you very much. If you have any questions, go for it.
Thank you, Alejandro. That was an absolute masterclass in practical performance tuning. Cutting a run from 10 hours down to 4, I don't think we can just call that optimization. I'm pretty sure that is QA wizardry. I know we have a couple of questions coming in from the audience, so I want to get some of those shared up live here. So let's go ahead and share this first one. What's the best approach to manage log verbosity across local runs and CI pipelines in Cypress? What do you think about that?
Oh, so that's a really good question. And this is based on my experience. So we have two options. One will be to explicitly tell certain commands not to show logs, because we have an option in almost every Cypress command to not log something, and this can be helpful when we are trying to click things. So we can leave out as many trivial operation and leave there as many assert operation as possible. So we will only base our debugging, our logs in assertions, which is the main goal of testing, to assert that the things we expect to be there are there, and those that are not are not. And also, the Cypress log filter plugin has helped me a lot. And there is an issue open, and I was working on it to be able to enable the ability to filter logs in case you want to search for something. So I would recommend those two: managing by using options in commands or using Cypress community plugins.
Excellent. We have another question here for you, kind of in the same line of best practices. Which single one of the things that you talked about here, other best practices that you implemented, had the greatest impact, do you think, on execution time?
Oh, thank you for the question. And this is a really difficult one to answer, because that depends on tiers as well. Because if we run a whole tier, reducing the time to load each spec file can make a significant difference. But if we are talking about running single isolated or maybe tiers with less quantity, less amount of test, maybe it could be of course, reduce weighting and replace them with assertion. If you have explicit weights in your code, do not just remove them, but also replace them with assertions, because we can leverage those weights and use timeouts to still waiting for the elements, and also reduce the flackiness of our test. So it is not just only about reducing the time, but also improving the quality of the tests.
Excellent. I have another question here for you from the audience. They were interested to know if you could talk a little more about the CI/CD changes that you made.
Oh, okay. So as I told you before, we parallelize our tests up to some degree. We couldn't parallelize our tests because they were coupled, some of them. So what we did was invest some time in identifying those tests that can run separately and trying to isolate as much tests as possible. And then we parallelize the test with a little bit of cheating, we can call it, because in our CI/CD pipeline, we deployed Conveyor can be deployed on Kubernetes. So we deployed two different namespaces, two different Conveyor projects, and we execute parallelization in a way that didn't that test data left by some tests weren't affecting other tests.